time is a crucial component of life, influencing how we view and engage with the world around us. So let's set out on this voyage of time comprehension together. Let's lay the groundwork for our investigation by comprehending the fundamentals of time. Events can be arranged in time in three dimensions: the past, the present, and the future. It controls every aspect of our daily existence, including our biological processes and routines. Have you ever considered how we understand time and why it appears to flow at various rates? A crucial component of human civilization has been the measuring of time. We have created a variety of ways to measure and keep track of time, ranging from ancient sundials to contemporary atomic clocks. What's the difference between conventional clocks and atomic clocks? Conventional clocks work on the basis of fixed time lapse. For example, if I start a stopwatch at sunrise and stop the stopwatch at exactly the same time, I would consider it as one complete day. If I were to fix this for every day, 365 days a year, I could call it a clock. I can go about my daily life relative to the time I calculated once a long time ago. However, atomic clocks aren't made like this. They operate on the basis of movement of atoms. These clocks are much more accurate as compared to conventional clocks. Let's just leave it at that for a little bit. Let's understand time relativity for now. Einstein proved that time is relative. According to Einstein, an observer watching a thing in motion will experience different time as compared to the thing in motion. The faster the object travels, the slower the clock ticks for it. This theory has been verified under different conditions. For example, an atom with a lifespan of 5 picoseconds was accelerated in a particle accelerator. It was observed that the lifespan of the atom was increased at highest speeds. Similarly, Einstein's theory of relativity claims that objects near high gravitational fields experience slower time. It means if an object was orbiting around Earth, it would feel a bit faster time as compared to the condition where it was orbiting Sun from the same distance. This theory was also confirmed by different experiments. For example, atomic clocks on the Earth's surface are a bit faster as compared to atomic clocks on a satellite. Now that we know what time relativity is, let's go a bit deeper. What about completely stopping time? Is it possible? According to Einstein, time will completely stop for an object under two conditions. One is traveling at the speed of light. If an object achieves speed of light, time would completely stop for it. It means if you are traveling at the speed of light, you can stay there for as long as you like. When you come back to normal speed, you would come back exactly in the moment you left. How fascinating, right? Well, don't get your hopes too high. It's not possible for us to achieve the speed of light. Why, you might ask? Well, one of the reasons is that our technology isn't on that level yet. We haven't even achieved 10% of that speed so far. Another reason is that, according to theory of relativity, your relative mass increases with the increase of speed. It means that we kept accelerating. We would be increasing our mass until our mass reaches infinity, which is obviously not possible. For now, at least. Another way to stop time is to go near heavy objects. Since we know that we experience slower time near objects with higher gravity, we can go near the heaviest objects to attempt to stop time. What could be heavy enough to completely stop time? Black hole. Black holes are intensely dense objects with so intense gravity that even light can't escape from. If we were to go near a black hole, we would experience no time relative to our friends here on Earth. But how will we get out from this black hole if even light can't escape it? Well, that's a topic for another video. For now, let's get back on our ship of time. Can we travel time? Access of past and future is something we all dream of. How can we travel time? We just learned that when we are around objects with very high gravity, or when we are near the speed of light, time ticks slower for us. According to this, we can stay in these conditions for as long as possible, and when we come back, we will return back to the future. However, it is much more difficult to travel to past. Scientists believe we can travel back in time through wormholes. However, there are still a lot of mysteries following this, like the grandfather paradox. It brings our attention to the butterfly reaction of our actions. If someone were to travel back in time through black hole, he could potentially alter the events of the past. For example, if you were to spawn in the room of Einstein while he was working on his theories, it is quite possible that your mere presence could alter everything in the world. Answering this is another theory which claims that there are infinite timelines. The moment you go back in time, you will create another timeline, which will not affect the original timeline. Then another timeline is added when another person travels back in time. It can go on infinitely. Nevertheless, this is just a theory as of now. We can only wonder what more secrets time has been keeping from us. That is all for today. We will return back with another fascinating topic. Give this video a thumbs up if you enjoyed it and subscribe to our channel to see more thought-provoking debate.